Right. Hello, everyone, and welcome to today's Skill Up series. My name is Emily Springer. I'm an academic trainer in the Graduate Studies Support Center, formerly known as the Center for Teaching and Learning. And we are very excited to have Dr. Sharon Kimmel come and present today, quantitative methods and hypothesis testing. Just a couple of housekeeping items before we jump into today's session. I am recording our session today. I will post it in our Graduate Studies Support Center webinar section. We have the chat available to you, as you can see, so feel free to participate in the chat. I also have the Q&A function enabled in our Zoom room today, so if you have questions, feel free to pop some questions in the Q&A, and we will get to that as time permits. The other two housekeeping items I want to mention today is I do have the scrolling subtitles on for the Zoom. You are welcome to enable them or disable them based off of your preference for viewing during our session today. And the other piece I want to remind you of is our Skill Up series has moved to a meeting format. So you are welcome to turn your camera on or off, but we do ask that you remain muted unless called upon. So that helps with the best flow of our presentations. But that about covers my housekeeping items, Dr. Kimmel. I'm looking forward to passing this over to you so we can get started.
Okay. Hello, I am Sharon Kimmel, and I currently serve as the Director of Assessment and Accreditation in the School of Business and Economics. I have been with the NCU-NU merged schools since 2013, I believe it was, over 10 years, serving in capacity of dissertation chair and committee members. And also prior to that, I have worked with physician residents and physicians and in healthcare administration doing research. So let's get started. Before we get into too much, I wanted to talk a little bit about the terms that I'm going to be using. The first term is what is quantitative research methodology? And it's just a highfalutin way of saying method. But a method is a science, and actually quantitative research methodology or designing a research plan is also an art. So it's a science and an art of planning procedures for conducting studies so as to get the most valid findings. And of course, using quantitative testing. Therefore, it's a set of instructions for gathering quantitative evidence, for testing the data that you've collected, and for interpreting it. The next term that we'll look at is what is a hypothesis. And a hypothesis is a prediction. It's important that this prediction is based on observation that is supported by gained knowledge around the research topic. It is a relationship between two or more variables, and it asserts that changes in the measurement of the independent variable is thought to be the cause of an affect on the dependent variable. So how does this relate to your dissertation research projects? Oh, I'm sorry. There you go. You make predictions based on observation and previously gained knowledge every day. For example, when you see a bit of sun and cloud, you make a prediction of the possibility of rain, and perhaps support it with expert opinions such as a meteorologist. And then you make the decision based on what you know and what you've learned from your expert in the field to decide whether you should take an umbrella or mow the grass or wash the car or whatever plans you happen to have for that day. You've often heard of research as comparing groups. When we think of group comparison, we often think of the case when the research is able to manipulate the independent variable. for your dissertation research study, the ability to manipulate your independent variable is very rare. I've served as a dissertation chair for over 75 dissertation research studies here at NCU, and I've served as a committee member for another maybe 300 or so. So during this time, I probably recall only about 2 what we call quasi-experimental group comparisons that I chaired, and maybe a few more that I served on as a methodological committee member. I was fortunate to work with a dissertation candidate since graduated who had an existing phenomenological exercise program that she developed. She also had the connections to implement her program and be able to perform a quasi-experimental study using a control group that received the standard curriculum and an experimental group that received her supplemental program. She was able to get parents' permissions and to collect pre and post phenomenological measurements. This is, like I had said, very rare. More likely, your group comparisons for your dissertation might look like comparing groups on an existing independent variable. For example, one of my dissertation candidates since graduated used an established survey to measure problem-solving style preferences between the general business and accounting majors at an undergraduate level. Another candidate since graduated compared job satisfaction levels using Hertzberg's hygiene factors as a framework between groups with a varying frequency of workplace chaplain contact. The group comparison is not out of reach for a dissertation research study, but the ability to manipulate and control your independent variable probably is. The other kind is the relationship study examples. It's this kind. I think I clicked too much. This is a prominent type of research study, and it explores relationships. Examples of relationship studies that I've done or had the honor of guiding are, I had a dissertation candidate since graduated that explored the relationship between a law firm's leaders' level of transformational leadership. Excuse me for a second. I had a dissertation candidate since graduated that explored the relationship between a law firm's the leader's level of transformational leadership perceived by the employees and the employees' level of engagement. I had another graduate who gathered data from a public database of New York Stock Exchange firms to explore the efficacy of Altman's Z-score. Another example is a structural equation model that a graduate did to test or to explore differences in public school safety training needs across multiple predictor variables. So this is the only really in-depth kind of eye glaze over part of the presentation that I'm going to present. Are you ready? I'm going to take it slow, not only for you, but for me, because it gets a little bit complex. So, and I want to make sure I've got the terms right. So when I developed this presentation, I struggled with how much statistical computation background I should delve into. I think it's important to explain why we develop hypotheses, because you typically will not see these or have declared hypotheses in the journal articles that you're reading. However, this is not a stats presentation, so this is going to be an overview, a high-level overview of the central limit theorem and the normal distribution. I couldn't possibly do this topic justice given our time, and there will be some gaps in this part of the presentation. Plus, I'm going to need you to make a leap in the visual, and I'm confident you can do this. Many of our statistical analyses, particularly our parametric tests, require that our data follow a normal distribution. The normal distribution has several properties that make it useful for inferential statistics. Inferential statistics is about taking samples and using the sample results to make predictions. The central limit theorem tells us that given a sufficiently large sample, the variability of the data set will follow a normal variability around the mean. This is a visual of the normal distribution. Have you ever seen this bell curve before? Well, we could use it to visualize a single measurement for an entire population. So let's say the likelihood on a scale of 1 to 100 for a person to go out and seek knowledge when faced with a problem. We will call this independent learning. Within this bell curve are the independent learning values for all the people in the universe enrolled in a doctorate program, all within this bell-shaped curve. And this is the mean. You know the mean. It's the average. It's what you've been computing since you've learned how to compute your grade average. The closer to the mean, the more data points or values there are. These are standard deviations. They provide a guide to how far away from the mean the data points fall in a normal distribution. So you'll see that approximately 68% or 68.2% of the data points or values for our independent learning measurement fall within one standard deviation from the mean, or in this range. And if you'll notice that on either side of the mean, there is a mirror image. So 34.1% and 34.1% equals 68.2%. So these are independent learner values below the mean and those above the mean. Likewise, we've got 95.4% of our entire universe, the values that fall 2 standard deviations on either side of the mean, and then we've got 99.7% that fall 3 standard deviations. These are called tails. And although it looks like in this diagram, the tail does end, it really does not. It kind of extends indefinitely. And there's always something underneath this tail. So according to the central limit theory, the further away from this mean that a data point falls, the more likely that data point is unique or is by chance. We can use this to conceptualize hypotheses testing. Here is where I'm going to need you to change your mindset. So let's say we have retrospective or history of all people in the universe that enrolled in a doctorate program, and we can group them into graduated or all but dissertation, the ABD. Then we test the difference between these groups. So instead of these data points within this bell-shaped curve being a single measurement of independent value, learning value, think of the data points as a difference in independent value between your groups. Now, after some fancy computing and standardizing, the statistical test provides us with what we call a statistical effect size. When we're performing our statistical analysis on our sample, because we can't do the full universe of all doctorate students, we will use what is called a null hypothesis. That is, it's a declaration that the effect size for our sample is less likely the further away from the mean or the center. And we can use this conceptualization of the central limit theorem and normal distribution. So the values that we're talking about represent the variability in our sample between the two groups. And we call it the effect size. And it's the difference in independent learning between the graduates and APDs, right? And if we think that we're comparing this with our population at large, because we only have a sample, we can compute a proposed mean and variability using the central limit theorem. You've often heard with statistical testing that we're looking at what they call as a p-value or a probability value of 0.05. And this is the common p-value. So note that the two p-values or probability values on either side of the mean can look at approximately 95% of our group, right? So let's use these values as a guide that we're 95% confident that our effect size will fall somewhere out here if it is unique enough to not be by chance, meaning that there is a statistically significant difference between the groups. So your question might be, given my sample, how likely am I to see an effect size of independent learning likelihood between the two groups as extreme enough as if there is a real significant difference? And that leads us to the null hypothesis of there is no statistically significant difference. That would mean that we're 95% confident here that our value would be within here, and 5% that it would be in here. So effect sizes that fall within these ranges are considered statistically significant, these ranges. And we reject our null hypothesis of no difference between our groups or variables. So to briefly recap, the concept of the central limit theorem may be applied to our statistical test of difference or effect size, which is realized from our sample. And researchers may, in advance, a priori, set the significance level or the p-value and the direction, meaning you're saying it could fall on either side, and that is a two-tailed test. Or you could predict that the difference would fall on one side, and that's a one-tailed test. And this 2.15% will move over a little bit. A p-value of 0.05 just may be interpreted that there's a 5% chance that the difference occurs by chance alone or is unique enough. And let's say we set a p-value of 0.01, which may be interpreted that there is a 1% chance that the difference occurs by chance alone. Okay, that's it. I'm done. But we will kind of revisit and come back to this conceptual theory as we move along forward. This is an outline of research methodology, which is purported by Andy Fields. I selected the Andy Fields outline because many of our research students and our dissertation candidates find his book, which is called Discovering Statistics Using SPSS. They find it to be easy to use. And I included a slide of resources at the end of this slide deck that you can, take a screen capture of and use it for further independent learning. Fields' text is pretty good. It's a good how-to book. And I also refer students to the Laird dissertation website, which is also a very good how-to, and also cited in the resource slide. So Fields purports 5 steps in the research process. You'll note that I did a little bit of moderating at the beginning and up here at the beginning. And at the end, added a 6th, and I placed his steps in phases. His reason, well, I broke down generating a theory to explain your initial observation, which he had as number 2, and generating a research question based on knowledge and theory that he placed as number 1. And his reasoning was because that identifying or generating your research question based on knowledge and theory is a way of identifying your variables. And I do not disagree. However, I believe that as you go along, or I have seen in my experience that as you go along, you're going to be refining and reshaping and finessing your research question. And this is based upon what you read and gather more information on your research topic from the literature, based on how other researchers have defined and handled the same or similar topic and terminology. My conjecture is to generate your theory to explain your initial observation and then generate the research question based on the knowledge and the theory. So my conceptual phase is to generate a theory, and then there's the design and planning phase, which is to generate your research questions and generate your hypotheses. This is what we will be focusing on in today's webinar. The empirical phase of collecting your data and the analytic phase of analyzing your data and interpreting your analysis. The intent is to have a follow-up webinar later in late summer, early fall. So I incorporated this slide to provide an opportunity to just pause and remind ourselves about the importance of gathering information on your research topic and the importance of evidence that there truly is a problem worthy of the efforts of doing a research study before we craft our research questions and our hypotheses. In your dissertation, you will be asked to align a research problem statement, a purpose statement, and research questions. And you're going to develop the problem statement, purpose statement, and research questions upfront. And as I indicated, there probably will always be finessing as you learn more about your research topic. However, if you were to do that upfront and seek knowledge, you'll know more about the doableness of your research study. You'll be less refining, you'll have less refinement of your problem, purpose, and research questions. You'll gather the evidence that the problem is sufficiently burdensome enough for a research study. You'll get a feel for what other researchers have done around the topic and problem, which can give you some ideas. And you'll know where the gaps are. You're in a sense supporting what your initial observation is, and you're more likely to be able to develop an informed plan or research methodology and design. We already briefly went over, but there are 3 primary types of research design that you'll probably see within your dissertation, or that you'll probably use or see within a dissertation research study. And likewise, these are there are different types of research questions. There is the descriptive type of a research question, which basically asks how many, how often, how much. What you're doing is you're describing your data. These types of research questions do not hold corresponding hypotheses, so we're not going to go more into them, and they're not by themselves appropriate for a quantitative dissertation research study. Did you know that qualitative research studies also hold descriptive data such as counts and percentages? The next common or primary research study that you'll see is comparative. And comparative, such as comparing one or more groups that we had talked about. Typically, it asks, is there a statistically significant difference between the groups? You will, at minimum, have a null hypothesis and one alternative hypothesis. And comparative research studies are appropriate for a dissertation. There's also the relationship, where you examine relationship between two or more variables. This may be a simple correlation. For example, the relationship between job satisfaction and worker engagement. However, there's been many studies on the relationship between job satisfaction and worker engagement, but we don't know if one predicts the other. We could also have a relationship study where we do have prediction, where we might predict that one variable may influence another. And in your research questions, you will also have outlined your dependent variable, your independent variable, any covariates if you happen to have them. And you're going to identify your intent, such as the comparative, is there a difference between this and this, or when this occurs. The relationship is between or amongst. A couple things that I wanted to just give you a heads up on with research questions. You have to make certain that your research topic is, of course, doable, or it's researchable. You have to make sure that your research questions are objective. There's no personal opinion, and there's no judgmental words in your research questions.
Dr. Kimmel,
Yes.
would it be okay if I jump in and just ask one question about that relationship example?
Sure.
Does a relationship come down to a statistically significant relationship? And what are you measuring in a relationship example from that last slide?
Here?
For, oh, good question, but I think this question came up during the starting phase relationship.
Okay. I think maybe what it was is that I gave an example of a correlation between job satisfaction and worker engagement.
Correct, yes.
Job satisfaction and worker engagement have been researched, and there are surveys out there that can measure job satisfaction. There are surveys out there that can measure worker engagement, and the surveys could have been validated, if you will, or are considered reliable in most circumstances.
Okay.
In a correlational study, you're just identifying whether, if job satisfaction goes up by 1 unit of measure, what happens to worker engagement? Does that go up by 1 unit of measure, or down by 1 unit of measure, or stay the same? If worker engagement goes up, you've got a positive correlation. As one goes up 1 unit, the other variable will go up 1 unit. If it goes down, you've got a negative correlation where one goes up, the other goes down. If it stays the same, you've got no no correlation. But you're not predicting or doing a regression model to identify if job satisfaction predicts worker engagement, or if worker engagement predicts job satisfaction. It, that I know of, has not been identified whether one predicts the other.
Thank you so much, Dr. Kimmel, for answering that. And that actually does answer the question. Thank you.
Okay. So hypotheses are declarative statements, and they're going to include your independent variable, your dependent variable, your study population, and there might be some other qualifying factors that you've identified or discerned as you've gone through your literature. And the qualifying factors may limit your study population. It may identify how you're going to measure your variables. And we always start with a null hypothesis. The null hypothesis is no statistically significant difference. It's our core idea in hypothesis testing. Remember when we went back over the central limit theorem and we said we test for no significant difference and whether that effect size falls within either tails or one tail, enough to be considered not by chance. In the comparative group, we're simply indicating that or interpreting that the groups are not statistically significantly different. I think I have a typo there. And in the relationship design, we're just saying that one is not, that the variables are not either correlated or one does not predict the other, that there is no relationship between the variables. Note that it includes the same terminology as in the research questions. The null hypothesis is denoted by an H sub 0. So think null, no difference, and think sub 0. You have a set for each research questions, and you will have an alternative hypothesis. And the alternative hypothesis is denoted either as H sub 1, or some statisticians will do H sub A. And the alternative hypothesis is the exact logical opposite of the null hypothesis. So, oh, it's also called the research hypothesis, but it includes the terminology, the same terminology as in the null hypothesis. You don't want to mix and confuse terminology because you're going to mix and confuse your research and what you're telling your reader that you are exploring. Do you remember in the bell-shaped curve, we had the two tails? When you have an alternative hypothesis, you could simply state there is no statistically significant difference, meaning you're not going to predict which direction based on the mean, which direction or which tail it's going to fall into. We call those two-tailed. And you set up your statistical test as a two-tailed test. But if we want to say that we think the effect size will be positive on the facing the bell curve, right-hand side of the bell curve, into that tail, then we call it a one-tailed. Or if we think it's directional on the opposite side, we call that a one-tailed as well. So let's put together what we've learned and give some examples here. All right. Let's say, and this is actually from something that I had put into one of our courses. So maybe if there's a student out there that's taken the course, you'll recognize this. But let's say that a doctorate student in public administration reaches candidacy in 2019. And the reason I'm specifying the year is because some of the resources that I have here to support the problem is a little bit older. And the rule of thumb for your dissertation is to have evidence to support the problem or to state that your the research problem is worthy of a dissertation study. These need to be as current as possible and definitely not greater than 5 years, because what may have been a problem 3 or 4 or 5 years ago certainly is not a problem today. So let's say that they reach candidacy and they want to, their research topic is distracted driving. And they go to their chair and they say, I'm going to do my research on distracted driving. And they've done a little bit of research and they decided that the topic of distracted driving is very important and meaningful. So their chair then says to the researcher, so what is the effect or impact of distracted driving that serves as an impetus for you doing this in-depth research study? And the candidate, now researcher, goes out and does some additional further investigation and identifies that despite state legislature and public service announcement campaigns, the incidence of distracted driving accidents persist as a public challenge. And this helps to the researcher to further focus their topic of distracted driving. So if you'll notice here, the candidate used different areas and different statistics to support their problem. Center for Disease, National Safety Council, and Hoomer, which is another researcher in the area. By the way, these are hypothetical examples and additional evidence will definitely be needed for your dissertation research study. So the researcher comes up with a problem. And the problem that the researcher wants to address is, despite state legislature and public service announcement campaigns, the incidence of distracted driving vehicle accidents because of secondary task engagement, which we saw in the problem statement, which I didn't read to you, persists as a public challenge. What we do is we identify what our independent variable is. The independent variable here is the vehicle type. This is got a group comparison, and we've got passenger versus delivery. And then we've got a dependent variable, which is distracted driving, vehicle accident because of secondary task engagement. And our study population is US drivers. And our hypothesis is or our research question, is there a statistically significant difference in distracted driving vehicle accidents because of secondary task engagement between passenger and delivery vehicles occurring in 2018 in the US? And I'm going to pause here for a second because in many cases, our independent variable can be the difference between our two groups. So here's our research question, and we're going to build our null hypotheses. There is no statistically significant difference. Null hypotheses usually begin with there is no statistically significant difference in distracted driving vehicle accidents because of secondary task engagement. This is where we identify the type of driving vehicle accidents between passenger and delivery vehicles occurring in, and we put some more parameters, 2018 in the US. Our alternative hypothesis is there is a statistically significant difference in distracted driving vehicle accidents because of secondary task engagement between passenger and delivery vehicles occurring in 2018 in the US. Notice the terminology is the same, but the colors are not. Let's look at this for a relationship-based design. Now our dissertation candidate, she reaches candidacy in 2021. And I'm sorry, it shouldn't be a she. A candidate wants to look at police officer attrition because they're interested in the high attrition rate of US police officers, and the generic problem then is the high attrition rate of police officers, but they've identified that this high attrition rate occurs within the first 5 years of service. So again, our candidate is charged with providing evidence, and please note that additional evidence will be needed for what your dissertation problem is going to be. So given this evidence and the problem statement, I'm going to ask you what you propose the research study problem is. And let's briefly go through it. Police Executive Research Forum, a source, reported that 29% of police officers voluntarily resign in their first year of service, and an additional 40% voluntarily resign between their second and fifth years of service. You have a researcher who has reported that a moderate or negative relationship between job satisfaction and turnover intention or intent to quit in the US, based on their findings from a meta-analysis of 101 research studies. I am going to tell you that if you can find a meta-analysis on your research topic, that is a wonderful, wonderful gift to find. So we've got this evidence, and of course, you know that you'll need more for yours. We identified that the problem addressed is the high rate of US police officers within their first year of service. So Emily,
Yes.
can we ask what the independent variable might be? Is that the
Yeah.
first poll, the independent
Yeah.
variable? Okay.
Go ahead and look. Yes, what is the independent variable? Okay, participants, I'm gonna go ahead and launch a poll, and you're gonna take, put your selection for what is the independent variable.
Is it job satisfaction? Is it the US police officers? Is it intent to quit?
And since we're in an educational space, if you get the answer not correct, that's okay. We're going to learn as a part of this process. I'm going to just give it another second while folks put in their preference. So we've got about 60% have submitted. So I'm going to go ahead and close the poll in the interest of time. There are two more, everyone, so keep that in mind. All right, share the results. Poll 1, what is the independent variable? Can you see it, Dr. Kimmel?
I can.
Okay.
I can see it. And actually, the independent variable is job satisfaction.
That's okay.
And maybe I should have done this after we looked at the research question.
That's okay. No worries. This is a good learning experience.
So the reason that job satisfaction was the independent variable is because job satisfaction does not, what we're thinking, oh, let's do the second poll and then I'll tell you.
Okay.
The second poll, what is the dependent variable?
What is the dependent variable? And just because I know the recording doesn't show this, but the poll says, what is the dependent variable? US police officers, relationship between police officer and job satisfaction. And then the last option is intent to quit. And I have about, like I said, about 60%. So in the interest of time, I'm going to end the poll and share the results. We do have a mixed bag here as well, Dr. Kimmel.
Yes, we do. And I really hope we're just kind of playing with me. So, maybe the problem didn't necessarily explain things properly, and because it was an abridged problem statement. The reason that the dependent variable was intent to quit within the first 5 years of service and the independent variable was job satisfaction is because the job satisfaction that is perceived by the police officer is thought to have an affect or influence the police officer's intention to quit. And the study population was the US police officers. The research questioned, what is the relationship between US police officers' intent to quit, the dependent variable, within 5 years, which is the parameters around how the dependent variable will be measured, and job satisfaction. In this situation, very briefly, and I see we're kind of running low on time, but very briefly, what the researcher could do is the researcher could implement one of those validated or reliable job satisfaction surveys. And at the end of it, because when you're doing a survey and you're asking an emotionally charged question, and you might want to put it at the end, you could ask them their intent to quit. And you would do this with the police officers within the United States was, I think, one of the things. Yes, US police officers. And you could either say, what was your intent to quit within the first 5 years in job satisfaction, which then you're relying upon their memories, but you could also just confine this to police officers who have not yet put in 5 years of service. So if our research question is, what is the relationship between US police officers' intent to quit within 5 years of service and job satisfaction? Next poll, please.
You got it. Last poll for today.
Last poll. How are we going to start our null hypothesis? Are we going to start it with the phrase, there is no statistically significant difference, or there is a statistically significant difference or relationship?
Kind of jealous. I wish I could participate. As the host, I can't. All right. So we are about 65%. I'm going to end the poll. I know I should wait just a second longer, but okay, share results.
There is, where are we? There we go. There is no statistically significant relationship between US police officer intent to quit within 5 years of service and job satisfaction. The null hypotheses, H sub 0, null, there is no statistically significant difference. And then our alternative, there is a statistically significant relationship between police officer intent to quit within the 5 years of service and job satisfaction. I apologize if the evidence of the problem and clarification of the hypothetical example was not clear enough to identify the independent and the dependent variable. Just remember that the independent variable is the variable that you feel will have an affect on the dependent variable, or think of it as the dependent variable, or the value of the dependent variable might be dependent upon the value of the independent variable. Congratulations, you developed a research question and hypotheses. Are there any questions going forward?
And Dr. Kimmel, I have to say, as a part of a learning process and as a student myself, learning more about quantitative, research methods as a whole, I think it's okay if we get the answer wrong, because then we can look back and take a look at it again and then realize where that correct answer is. And maybe I'm just speaking on behalf of myself, but I'm sure other students on the call feel that way as well.
Actually, Emily, that's a really good point, and I appreciate you bringing that up, because I agree with you. Sometimes we do so much better when we learn from what's not appropriate, right?
Yeah, absolutely. And so, I do have a question in the Q&A. We have a little bit of time, so if anybody has any questions, please feel free to pop them in the Q&A or the chat. Thank you for going to the screens of these resources. If you could slowly go through them in case folks want to take a screenshot. But the first question that I have in the Q&A is, where does the two-tailed, one-tail and the directional come into play? That's one question. And then the second question is, do you use directional in your hypothesis?
Yes, very good question. Very good question. The directional comes into play when you are developing your alternative hypothesis. And if we were to use the example of the group comparison, where we were asking or exploring whether passenger vehicles have more accidents within that time frame due to secondary task, like texting or something like that. Do the passengers versus the vehicle, like delivery vans? In our null hypothesis, we would say no statistically difference. In our alternative, we could possibly say that vehicle vans might have greater. So it would be, there is a statistically significant difference in that passenger vehicles have greater task-associated vehicle accidents. And the data for this could conceptually come from a large database. I have gone out and seen it. There is a large database, and they do drill down to whether the cause of the accident was secondary tasks, such as texting or eating or something of the nature of that, secondary tasks performed while driving. So it would come in at the alternative hypothesis, and that drives which side that you feel your effect would be, that you feel your sample effect size would be from that of the universe. Does that answer the question?
Feel free to pop that in the chat if it does, or to ask a follow-up. Yep, that's a thank you. That being said, I did see something else come up about the hypothesis piece. And I'm glad you asked the poll question at the end, but would you mind explaining a little bit more about the null, just one more time for us, that null hypothesis and then your alternative, and
right,
why we base out one off of no and then the other is a different option.
right. Many times when I ask students about their hypotheses, they often think in terms of, and as in general, the population thinks that a hypothesis is a prediction, and it is, of something you think is going to happen based upon your experience, observation, whether other people have researched. So even though a hypothesis is a prediction, you're predicting passenger vehicles will have greater accidents because of secondary tasks than passenger vehicles, or the passenger vehicles versus maybe the delivery vehicles. But when we do our statistical testing, we are testing that there is no difference. So it's null. It is nothingness. It is that your prediction that one group is greater than the other is is not, it's a zero. The effect size is zero. That's what we test. That's how we've set up our probability values on either side of the bell curve in the tails. So although it might not make sense in the general definition of a hypothesis, it is the testing hypotheses for statistical analyses. I hope I explained that correctly. I mean, I hope I explained that clearly.
Thank you so much, Dr. Kimmel. I know we're at time, but I'm hoping we can answer one last question and then we'll wrap up. You mentioned the research question must be objective and not opinion-based. Can you explain what you mean by this?
Sure. The research question needs to be objective such that it is based upon a pure intent to explore as opposed to an intent to prove a point. That sounds maybe a little bit crude and maybe you don't understand where that's coming from, but many times I've seen where students want to prove a point and people talk about proving a point with research. You're not proving a point, you're exploring. And you need to make sure that your research question comes from a source of objectivity. I think this is what's happening, but I really want to explore and know with the understanding that it could go either way.
Thank you so much, Dr. Kimmel. I really do appreciate it. I'd like to thank our participants for participating and asking questions in the chat. Keep in mind that Graduate Studies Support Center is really trying to provide sessions that help you in your academic journey. So at the end of this session, you are welcome to participate in the survey and just let us know if there's more different materials that you would like us to cover for you in our Skill Up series so that you can be successful, providing tools, tips, strategies, suggestions for success in your academic journey. And Dr. Kimmel and I will be touching base to look at another option for quantitative research methods in the fall as well. So until the next time, Dr. Kimmel, thank you so much for your time. And I hope everybody has a good rest of their day.
Me too. Thank you, everyone. Bye.
Bye-bye.